Thanks, Brian. Hey, everybody. I'm Stephen Tobias. I'm a cloud architect at Red 8. And today we want to show you how you can use Kubernetes to help kind of simplify and accelerate AI or ML adoption. Just kind of a rough overview of the agenda, what I'm going to go over today. I'm just going to kind of like level set about like what is AI. It's a big space. There's a lot to talk about. So we're going to talk about what is it and kind of how it relates to our demo. I'm going to show you, and explain why Kubernetes is a great platform to use to kind of develop AI workflows. And then I'm going to jump into a platform called Kubeflow and show you how Kubeflow, almost like what a day in the life of a data engineer or an infrastructure engineer looks like, managing AI workflows on top of Kubernetes. And we'll do a little stuff in Jupyter notebooks to show kind of some data science. So overall, right, hold on, sorry, I think I've got WebEx stuff in the way here. So, AI is great, and there's a lot of companies that are using it to really kind of help develop more intelligent applications and further, some of their business goals. But it's really difficult along the way, right? It's a lot of new technology. You have to use things like shared storage and GPU to help with training and large data sets. And this is where, Red 8 can come in and help out, accelerate your AI initiatives and help you deliver AI applications a lot quicker. So at a high level, what is artificial intelligence? There's a few different subsets. The one that usually makes the news is in red here, deep learning. But as kind of a broader subject, AI is really just the capability of machines to imitate human behavior and perform tasks that normally require humans. And machine learning is kind of a subset of AI where a machine will learn through algorithms by itself without being explicitly told what to do. So using statistical algorithms or models, the machine will learn how to predict certain outcomes. And then deep learning is a subset of machine learning that's using many features through neural networks. And this is typically where you hear about things like computer vision and natural language processing and image analysis. A lot of that is through neural networks and deep learning. So why do we use AI or ML, or kind of what's possible? A lot of times, customer experience is a big thing. How do we better understand our customers, sentiment analysis with, reviews, or maybe gaining a competitive advantage and being able to predict market conditions. And overall, what you can use it to do is help increase revenue or maybe, reduce costs, predicting, when you're running out of capacity, things like that. And some common use cases along those lines across a few different verticals. AI is getting really popular in healthcare for doing things like diagnosis or a lot of cancer detection and things like that with image scanning. In financial services, really common to do risk analysis and fraud detection, and also kind of predictions of market conditions, and you're seeing it a lot there. And then kind of, automotive is one that everybody knows about and hears about, right? Through image recognition and reinforcement learning for lane keeping, really becoming popular there. And then you can also use it kind of in supply chain, right? How do you direct a robot to identify an object and pick it up? So there's a lot of use cases for AI and ML, but these are kind of just high-level ideas, right? How do we get there? And when you start to dig down into it, there's a lot of demand on infrastructure. So us as IT people, there's a lot of challenges that we run into when we try to enable these workflows. And a recent study kind of asked, surveyed companies that are deploying AI and ML workflows. And they asked, kind of what's the most challenging thing? Largely, people are talking about data preparation and management. So acquiring data sets, you need vast amounts of data to train machine learning workflows. So acquiring that data is often a challenge. Storing that data is a big challenge, and managing the versioning of that data as well. And then beyond that, the next step, once you've acquired your data and you've stored it, is training. Often you need a lot of specialized compute to do training on that data. It has to be very high performance compute. You hear about GPUs a lot in NVIDIA. And so, using that data to train and build a model. And then finally, you have to deploy and kind of at the edge inferencing, right? How do we utilize that model that we've developed and now make predictions using it? And so it's kind of evenly spread, where the challenges are across all three of these, pieces of the life cycle. And that's where, infrastructure can come in, and we kind of need a unified platform to help solve all these challenges. And just kind of an overview, as we move through those stages of the AI lifecycle, there's different personas, and different people run into these challenges. And so these are kind of like an overview of who's doing what. You might have these goals at the high level from business leadership. We want to use image detection to identify whether or not a car has been impacted for an insurance claim. And that's a very high level goal. And then from there, you get down towards the data science team where they have to gather the data. They have to do what's called feature engineering and identify different features within the data sets to make predictions. They use those features to build models. And then ultimately, you use those models and you serve them out. Your application developer might take the output of model development and implement it in their application and ultimately serve it. And so you'll have to pass through multiple different business units along the way. IT operations, we're pretty much involved in all of it because we've got to support the compute. And this life cycle, as we kind of look at it, excuse me, it's not too unusual. It's something we've known. It's something we've seen before. It looks a lot like a DevOps workflow. In a traditional DevOps, more code needs to be written, and you have to build and test, right? And then you have to deploy the staging and validate things, and then you release and ultimately monitor your application. It's very similar to the workflow of AI or ML data engineers. And so this is really where we can start to kind of accelerate AI initiatives by using kind of the lessons that we learned from DevOps. So conceptually, what does this look like? At the end of the day, this is actually backwards. I'm going to click through a little bit how I want to talk about it. So, you want to surface these tools, right? There's a set of tools that all of your data engineers and your application developers will need to use along the way. But, at the beginning, we want to be able to have a consistent platform regardless of our infrastructure. And so that's where Kubernetes really helps out, is whether we're on-premise and serving up locally with our on-premise hardware, or in the cloud, or maybe at the edge, we need kind of a unified platform to surface, at the end of the day, to surface compute to our developers. And that includes things like GPUs or TPUs, storage, and really we want a platform with self-service capabilities, kind of building up here, right? We want developers to be able to just go in, request what they want. I'd like a GPU to train my model. I'd like, storage to store all of my images, right? And they don't need to, they don't want to have to know about the backing infrastructure. They just want to be able to request compute, request storage, and then use a set of tools that's familiar to them to help develop these features and kind of move forward quickly. So Kubernetes kind of helps us build on all that and provide all these tools dynamically to end users. And so just to touch on kind of some of the tools here that we're going to need, right, to execute on this process of, AI and ML, this whole workflow here. Some of the tools you're going to end up needing are, the development stack, which is going to be things you may have heard of like Jupyter notebooks, which are a web interface to kind of interactively build, typically with Python machine learning workflows. You can use things like TensorFlow, which is a framework for developing machine learning algorithms. And then you're going to need data services, whether that be Kafka for data streaming, maybe object storage, right, through something like NetApp Storage Grid, or maybe Minio. And then you'll need other just traditional data services like, NoSQL or, MySQL, various other databases. And we want to surface all of this through a self-service kind of interface. So this is where Kubernetes is really great. Kubernetes allows us, we've kind of seen in DevOps, right? It's a very easy workflow. You just click and go, and it will be able, you can deploy your applications right away. You can iterate very quickly with deployments and automated rollouts in a unified system to surface compute to your applications. And it's portable, right? So you can deploy the same application on Amazon as Azure, or even on-premise. In our demo today, we're going to be using on-premise resources that we already had. And we're going to be surfacing, storage from NetApp and compute from VMware and GPUs in the same way that we might consume it from a hyperscaler. And so that portability is really a great feature in Kubernetes. And then it's, between flexibility and scalability, scaling up and down in Kubernetes is very simple. It's not like it used to be where you have to rack and stack and kind of keep things going, hands-on. And this is really why we think that containers in Kubernetes are really the best option to help accelerate AI and ML workflows. Excuse me. And this is where, Red 8 can really come in and help out. We've got kind of a proven track record over 20 years of working with companies, deploy and integrate hardware compute to really kind of accelerate business initiatives. We've got a, broad engineering skill set and team of engineers that can help you understand how to integrate various different technologies, to further your goals. And finally, we've got a lot of partnerships. Today, we're going to be talking about, VMware and NetApp and how we're using, NetApp's Trident software and VMware's compute platform to surface all that compute to end users in a seamless manner. Yeah. So getting closer to the demo, almost done with the talk. What kind of tool sets are we going to be using today, and what does it look like, when you're on containers and using Kubernetes? And Kubernetes allows you to simplify the deployment and scaling of your infrastructure, and that could be things like Seldon for serving or surfacing GPUs. You can seamlessly, consume those on Kubernetes without having to worry about, drivers or anything like that. We already talked a little bit about portability. Once we, develop this application structure, we can move it to any cloud. And then collaboration. This is a really cool thing that we're going to see here. We can provide a platform where any team can log in and build using whatever framework they want. They can use things like serverless, they can use Java applications or Golang applications. It really doesn't matter. There's a unified platform where anyone can go in and work on their product. And at the end of the day, something that I really like about Kubernetes and that really has driven a lot of its success is the fact that it's powered by the open source community. We're going to be using OpenShift today, and Red Hat's a big contributor to upstream Kubernetes. And what's cool about that is that, Kubernetes itself is open source, it's out there, and you can use it. And all these different companies are contributing to it, and that really leads to a powerful platform. So we've talked about this a little bit, some of the technical things that we're going to show today. So to kind of set an idea, or kind of rather like a scenario, right? Let's imagine that we're running a online store, and we allow customers to write reviews. They can write reviews of whatever they buy from our store. But recently, maybe we've seen a high uptick of certain sellers on our store gaming the system. They'll hire, spam writers to just put fake reviews out there, or maybe they're using some kind of automation to put fake or spam reviews on their products. And so we want to improve the customer experience by filtering out those spam reviews and really just raising the quality of actual reviews on our site. So what we're going to walk through today, hopefully you can see my mouse. We're not going to touch too much on gathering or preparing data. We're going to assume that we have a data set, and I'm going to show you how we load that in. But really what we're going to focus on is kind of the later part of the life cycle here after we've acquired our data. And I'm going to show you how we can use a single platform to find features within those data sets. And then we're going to use those features and operationalize them into an application, all within kind of the same interface together. What's powering our stack? So I've mentioned a couple of these companies already. It's a range of open source products. Over on the right here, this is closer to what the code is. So we're going to be using, in this case, Jupyter notebooks, and we're going to be using Python libraries called scikit-learn. The platform that we're going to be walking around through today is called Kubeflow, and we're provisioning, or we're surfacing hardware to these applications. We've got NVIDIA GPUs on the back end. We're running Kubernetes in a VMware environment, and NetApp is providing us dynamic storage through their Trident plugin. And we kind of put that all together. What we're going to be using today is Open Data Hub. That's just kind of a packaging of these open source components together. Mostly the Kubeflow components packaged into Open Data Hub, just as kind of an opinionated distribution. Okay, and so just a last little bit about what we're going to be doing. We're going to jump into a Jupyter notebook. We're going to do some feature engineering and then deploy onto OpenShift an application that will serve and respond and make predictions to what we send in. Okay, so demo gods be with me.
And don't forget, while Steven's setting that up, don't forget he is available for questions.
Yeah, so if there's any questions, happy to take some before I get really into the demo here, but if there aren't any, I'll just jump right in. Okay, so this is Kubeflow. So this is a kind of platform that you can use to deliver machine learning services within your business. What's great about Kubeflow, it has kind of this nice interface that you might expect from a cloud provider, but you can provide it anywhere. Kind of right off the bat, what you see, you can run pipelines, full machine learning pipelines in Kubeflow. So that means like training or acquiring data and deploying, that can all be executed through the single platform. And then what we're going to start jumping into here is notebooks. So we provide an interface for end users to just come to us and by themselves request, a notebook. So if I have a project I'm working on, reviews.
Could you increase your resolution a bit?
Oh, yeah, hold on.
Rather decrease it.
Is that better?
Thank you.
Yep. So within the Kubeflow interface, what we can do is we just allow users to come in, multi-tenant users. They can request, to spin up a specific container image they'd like that has a set of, dependencies that they might want to use. They can request how much CPU and memory they'd like for their application. We can assign as administrators quotas on how much users are allowed to provision. So I can say, the finance team is only allowed X amount of compute and storage. Each user gets their own persistent home workspace. And then beyond that, we can either request new storage from our storage provider backend, in this case, Trident, or we can, mount existing volumes. So if we have existing data sets, we can just clone them into our workspace and not affect the production data. So we can provide that data almost as a service, using the NetApp storage plugin. And then also, if we have GPUs in our cluster, we can allow users to request however many GPUs they want. Just at the click of a button, they can say, I'd like, a GPU, and launch. So jumping into it, assuming I've provisioned myself a Jupyter notebook, it looks like this. I can clone in some code and then just jump into one of these notebooks here. And, as I talked about in the life cycle, starting over at the beginning of it, what we want to do, I'm just going to kind of walk through these a little bit, is we're going to load up some data that maybe a data scientist has prepared for us. Let me show you a little about what that data looks like. So if we say data like this, our data is roughly, it's just a block of text, so the review. And then it's been labeled by other business processes before us as either legitimate or spam. So some of these will say spam. It looks like the top is a lot of legitimates. Some of them are spam. So what we're going to do is we're going to use a machine learning algorithm provided by scikit-learn, which is a Python framework. And essentially what it's going to do is score a block of text based on certain characteristics, in this case, word frequency within a document. And we're going to see, does that provide us a good score to determine if it's spam or not? So I've got a couple little blocks of text here pre-made. Essentially what I'm doing is taking the review text, assigning it a score, and then I'm going to print those, identify features, within those vectors there. And then I'll show you what it ends up looking like. When we score each of these blocks of text, they're either assigned a value, 0 is at the middle here. If it's more than 0, you can see that we've got a clear grouping of emails that are, or not emails, sorry, reviews that are scored as legitimate and some that are scored as spam. So it looks like we've found some features that do tend to group emails together one way or another. That's great. So let's see if we can use that data and those features that we've just identified to train a model and validate, if it works and kind of tune it a little better. So we're going to use what's called a logistical regression model to filter between the two. So we're going to take those features that we just took, or sorry, the features we just created. You can see here's the feature data. We're going to load our testing and training data. This is what we're going to use to validate the model and see if these features accurately predict spam or legitimate reviews. So again, we're loading that previous data here. We're going to train the model, and then we're going to make some predictions with that model. So you can see here in the predictions, there's a better way to show this. I have train. So I have some data, and then I pass that data in to the predict method right here. And in the end, my model is going to spit out Okay, item 1 was legitimate, item 2 was spam, based on those features. Usually how you visualize data like this against your validation data or the pre-labeled data, you want to test if your predictions match what your human labels are. You can use what's called a confusion matrix. And essentially what the confusion matrix is, it shows, up here in the top left, that we have correctly labeled these. You can see like the difference here where this is a lower count and it's closer to 0. We're predicting accurately. We're accurately predicting spam where our actual label matches our predicted label. So we've predicted spam with 4,000 and 4,000 of those were actually labeled spam. We were incorrect 257 times, but overwhelmingly our model is pretty accurate. Oops. Yeah. Excuse me. So this is just another way to look at that data. This is what we're seeing in the confusion matrix here. You can see that, the predicted value versus the actual value, how many times we did that, and what our accuracy is. So we were about 94% accurate predicting legitimate. We're about 97% accurate predicting spam. Just a little bit more, metrics that we can output about how accurate the model was. And then at the end here, what we can do is we can save that model. So I'll save that model. So just kind of where we are in the workflow now, we've collected our data. We've found some features. We've now trained and tuned a model. We know that our model can accurately predict whether a review is spam or legitimate. Based on our pre-existing training data. And so now we're kind of down here in the workflow. So how do we use this same platform to now deploy our application and serve some predictions, right? This is all great, but it's just in a scientist notebook right now. How do I use it in the real world? How do I know if reviews are spam or not? So I'm going to jump into OpenShift. This is just a developer work, kind of developer view here. What it's showing you is what's running in my cluster. A little busy right now, but I have some pre-existing deployed applications. I've got a Kafka stream in here. I've got a couple web apps running, and they're kind of grouped up here. You can click on any of these, and it'll show you, okay, I have 12 pods running this application. We're not going to deal with that application right now. I'm going to deploy that model that we just walked through. So I'm going to click Add from Catalog. We have a catalog, through OpenShift and Kubernetes. We have all these applications we can deploy. Whatever I'm working on, I can use my own framework. In this case, I'm going to use a specialized template for scikit-learn. And I'm just going to say this is our webinar test. I'm going to paste in our Git repository that we've been working on. This contains all of our notebooks. And then you can see here, I'm passing it a list of the notebooks that I've been working on. And what this build image is going to do, once I create this template here, this is going to go create a full build and deploy of the application using those notebooks. So it's going to convert my notebooks to scripts. It's going to run those scripts. And then use that output, when we saved our features and we saved our model, it's going to use that output to serve predictions at the end of the day. So let's walk through what that looks like. So right over here, you see our webinar test application has been deployed into the environment. Right now, it's in the middle of a build. You can see right here in the interface what's going on. Build 1 is running. It'll take a minute here. So the build image is downloading all the source code from Git. We've passed some arguments about what notebooks we'd like to convert into an application. Make it a little bigger again. Sorry, guys. And then in just a minute here, it's going to start building out that application. Great. It's installing all our Python dependencies. So these are the same ones that we provided within our notebook image. It's the worst part. It's quite fast, but it feels slow. At least when you're on camera. So I guess some of the context I can provide while this is running is that within the OpenShift platform and using Kubeflow, we have the same auth scheme between these. So you can see here, I'm in a project. You can delegate projects to different users or different groups and assign them quotas and resources, how much they're allowed to build and how many notebooks or GPUs they're allowed to provision themselves. And it really kind of allows that self-service experience. So you can see here, this is some of the output that we saw from our feature generation. These are kind of some of the scores that it's giving us. So it's building that application. Here is the precision kind of output of our model. So it's just finishing up the model training step. And now that we've got all that done, it's going to take those files. It's going to commit them to an image with a specific tag. And then magic is going to happen. Our little config here, once it finishes building, is going to spin up a pod on the fly, and we'll be able to serve traffic to it. So just another minute while it finishes building, and then we'll see this scale up, and we'll be able to test some actual data. It's pushing the image right now. So there's an internal registry within OpenShift, which again matches our auth scheme. It's just pushed to my team's projects registry. And there we go. As soon as I click away, it is finished building. You can see we're now creating a container. We're in this guy right here. Our container is creating. We can click again to view logs of that container if we'd like. We'll show that in just a minute here. But right now, we're just waiting for it to spin up. It's pulling the image down from the registry. And then once we pass a couple health checks, there we go, we're running. We've passed our health checks. You can see the applications running over here. I'm gonna go ahead and create a route for this application so that we can access it and send data to it to predict if it's spam or not. So I'll just go down here to routes, create a route, live demo, prediction service. And we're gonna send it to our webinar test service, webinar test. We're going to pick that 8080 port. So this is the integrated load balancer provided by Kubernetes on OpenShift. We don't have to worry about going out to whatever our provider is. We can just click, I want a load balancer, just like the cloud. Okay, great. So now we've got that service all spun up. You can see it's serving traffic. I'm going to take that URL. And we're just going to kind of walk through an example of how we can make predictions with it. So I'm going to paste that URL in right here.
Stephen, can you blow up your resolution again, please?
Yep. So this is just another workbook that's going to show you a quick example of how we could send traffic to it. This could be an end user, a web service, maybe an application. But our application, our model is online, ready to serve predictions now. So we're going to use that base URL. We have a little function here that's just going to post some data. So it's going to send some data to the application and then get a response back that tells us whether it's predicted to be spam or not. So right here, we're just going to say, okay, tell me, is dog food spam? Or is, is truth a universally acknowledged, message? Is that spam? So I'll go ahead and run that. Oh, don't fail me now. There we go. And essentially, the way this model has ended up working is that more complex reviews, right, will tend to be more real. They have actual more information in them. So if we have a more complex sentence, it's going to be marked as legitimate. And then, so let's take a bunch of our training data, right? And let's fire a bunch of those through. So you can see here just an example, we've iterated through our training data and we've scored each of them. The prediction is over here in the right-hand side column. And you can see each of the kind of text predictions here, but we're actually getting this from the live service now. So what's cool, I'm going to change this just a little bit so I can see metrics. If we keep going down the list here, our model has metrics surfaced through Prometheus. And I've set up a pre-baked dashboard so I can view metrics of my service, right? So if I click Get Metrics, we're querying Prometheus, and it's telling us all sorts of things about, how many predictions we're making of spam and how many predictions we're making of legitimate reviews, and how long it's taking to make these predictions. All sorts of stuff you need down the line in the life cycle to make sure your model is still healthy. So I'm going to run a little function here just to show, if we jump over to the metrics, this application that you saw earlier, I'll jump into it right here. This group of applications here is continuously producing just some, it's reading data and just kind of hitting the web service, generating some load. And so you can see here, we have a pretty stable line of predictions. We're pulling those metrics that we just looked at. And if we mouse over them, again, the blue line shows how many predictions we're making that are legitimate, and the green line is how many predictions that are spam. And over time, maybe our model, might not reflect what's actually out there. And so we want to be notified, if we're starting to see a lot more legitimate emails, really we'd expect to be getting roughly the same amount of spam, or we'd want to know about that divergence. So if I generate, just some traffic here through this experiment function, what's really cool is that, again, without leaving the platform, we've got all the metrics and we know how our model's performing. And we'll be able to notice a diversion from normal. And we could alert on that. And then maybe we know then to go back and retrain our model on a new data set. So if I generate some traffic, and you'll see here, I'm going from mostly spam to less spam. And so we'll see kind of a divergence in those two lines in the metrics there. Little bump. I'll give me a bigger bump. I'll send a few more. We'll go like this. Send a lot of spam. You can see a little uptick. In real time, we're monitoring our model. We know what predictions we're making, and really, what the ratio is of, spam to legitimate predictions. It's small, but eventually this will pick up. Come on. But in general, you can see that we'd be able to monitor, what's called data drift within our model. So that's all I had for today. Happy to take any questions. Yeah, using Kubernetes and Red 8's happy to help out with it as well. At the end of the day, what you end up with is a unified platform where Ops is able to offer all the features that the developers need. Data scientists have all the tools they need. It's exposed to the right compute. And at the end of the day, that means, happy developers, happy life, right? So thanks for your time today. If there's any questions, happy to take any. Thanks, everyone.
Stephen, there is one question in the chat. Don't have a name, but it says, what was the tool you used to build your application? Kubeflow or OpenShift?
Sure, so I can show that. Excuse me. So Kubeflow is kind of like a self-service platform, right? Kubeflow allowed me in the developer persona to create the application. So, as far as coding it, a lot of that was done in Kubeflow here. And then for the purposes of the demo, I used OpenShift for the build and deploy portion. So Kubeflow is hosted in OpenShift. So OpenShift is providing both Kubeflow and then the method for us to build and deploy that application. So OpenShift builds the container image, deploys the container image, and then serves that REST API. Hopefully that answers the question. H206604.
Awesome. Thanks. Thanks, Stephen. Any other questions? Last call for questions. And then we do have just a guest speaker for a second, and then we'll end things. All right. Well, gave the pause. So we do have in attendance today our SVP of Engineering, Rob Cotter. And just wanted to introduce him real quick, and he just wanted to say a few things before we close out for the day. So Rob, pass it over to you.
Yeah, first of all, thank you everyone for attending, and thank you, Stephen, for putting this on. I just want to let people know that we have, if some of this kind of catches your eye and you'd like to kind of do a deeper dive into the technologies that we've used, or maybe even further upstream in terms of looking at different use cases that you might be thinking about and coming up with a data strategy. We do have a promotion where we're providing workshops in partnership with some data scientists to help people strategize and kind of get their arms around the kind of the front end ideas of, like I said, the data strategy or models that they might be able to use, that kind of thing, all the way to this workflow that Stephen just described. So if you'd like to go deeper into something and that in regards to AI, please let us know. You can reach out to us at ai@red8.com. And Stephen has kind of brought up a PDF here of the workshop, a description of the workshop. So if you're interested, again, ai@red8.com, and we'll get back to you as soon as possible. Thank you.